For this problem, we have that W is equal to the set in R2 where both X and Y are rational numbers. And now we're asking whether or not W is a subspace. For W to be a subspace, we need three things. We need, one, the W not be empty. So W is not empty. Two, we need W to be closed under addition. That means that if you take two elements from W and you add them together, it still isn't W. Is closed under addition. And finally, number three, we need that W is closed under scalar multiplication. That means if we take an element of W and an element in the real numbers R, and we multiply them together, it should still be in W. Okay, so now let's go ahead and see which ones work, which ones fail. So number one, we know the point 0, 0 is in W because 0 is a rational number. So that's good. W is not empty. Now let's take a look at number two. If we have two elements in W, let's say x1, y1 is in W, and x2, y2 is in W, well, that tells us that x1, y1, x2, y2, that's all in W. And if you add together two rational numbers, you're going to get a rational number. So this means that x1, x2, and y1, y2, x1 plus x2 and y1 plus y2, those are rational numbers. Oh, I have a typo right here. This should be the rational number. So this should be the rational. It's not Q. Excuse me. Okay, so this tells us that when you add these things together, you get an element that's in W. So W is closed under addition. Okay, so the problem is closed under scalar multiplication. So if we consider a point in W like 1, 1, 1, 1 is definitely in W because 1 is rational, but let's take the square root of 2. This is an irrational number. And if we take the square root of 2, we multiply it by 1, 1. That gives us the square root of 2 times square root of 2, square root of 2. But this is not in W because the square root of 2 is irrational. And so W is not closed under scalar multiplication. And that's it.